What's going on, guys? My name is Steve. Thank you for stopping by my channel. Today we're going to be reacting to Is the Metric System Actually Better? A few months ago, I reacted to a video titled Why the Metric System Matters. In that video, I definitely learned quite a bit about the metric system, but I felt it didn't really do a good job of fully explaining the differences between the imperial system and the metric system. While I was hoping to come away from that video with the ability to fully understand how to do measurements with the metric system, for the most part, I really didn't learn all that I wanted to learn, but I definitely learned a lot about the history of the metric system and why the metric system is so important today. Obviously, the metric system is known to be the universal measurement system of the world, but for some reason, here in the US and maybe a few other countries, we still use the imperial system. I don't know if that's because it would just be very expensive to switch over or whatnot, but I know when I was in school, I didn't learn anything about the metric system. I learned the imperial system completely, and I got out of school and didn't know anything about the metric system. And honestly, up until that last video that I checked out about the metric system, I still didn't know anything at all. And so I'm hoping in this video I can kind of learn how to do measurements with the metric system and just maybe learn a little bit more detail about how the metric system works and why so many people say it's much easier than the imperial system. You know, as someone that is from the US, I find the imperial system easy. And so it's going to be really interesting to see if I truly think the metric system really is easier than the imperial system. But anyways, guys, don't really know what to expect here, but this should be interesting. So let's just go ahead and dive in and check out, is the metric system actually better?
The time has finally arrived. The comment section demanding imperial and metric units has gone on too long. There can only be one measurement system. The British imperial system, like everything British, is based on antiquated units of measurement, like measuring your country's importance by counting the number of countries you have invaded and pillaged. A measurement that made sense 100 years ago, but it's time to move on. Weirdly, the British have mostly moved on from this method of measurement, and it is instead Americans who insist on holding onto it. Well, America, Liberia, and Myanmar, a prestigious trio. Now, I can already hear the people who refuse to wear masks in the comments. There are two kinds of countries, those that use the metric system and those that landed on the moon. You know who led the design team for the Saturn V? This guy. Listen to that deep Alabama accent.
This weight dictates the amount of fuel and the numbers of motors.
An American through and through. Ignore this photo of him. Those are just some German friends he made while on gap year in Europe. Look at all his friends. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 9 friends. A popular man. This Alabama native used metric. In fact, he despised British units. So much so that he designed a rocket during his gap year to fly to England to show them how great the metric system was. The Saturn V was designed, like nearly everything in NASA at the time, with a mixture of both metric and imperial units. Just read the mission reports for Apollo 11 for proof of this. It switches between inches and centimeters constantly. It's a mess. Anyone working with this report would have had to be hyper aware of what unit of measurement they were using. Most of the design and science work was done in metric, before being converted to imperial for the manufacturing and operational staff. One of the most mind-boggling examples of this is the guidance computer. It was coded in metric. Meters and kilograms are the language of science. But to ensure the astronauts could intuitively understand what those calculations meant, the displays inside the lunar module had to be displayed in British imperial units. So, even back then, when computer power was extremely limited, the engineers had to waste precious computational time and power to conversion. And this isn't just a waste of computation power. Errors in conversion have led to an insane number of accidents through the years.
Yeah, I can imagine.
Some of the most notable being in NASA. In December 1998, the Mars Climate Orbiter took off from Cape Canaveral aboard its Delta II rocket. Over the course of its 9.5-month journey, the orbiter needed to complete trajectory correction maneuvers to bring it into an optimal orbit insertion altitude of 226 kilometers. However, as the time grew closer, calculations showed that the orbiter was entering Mars' orbit in a far lower altitude, so low that it was likely going to strike the atmosphere and violently tear itself apart. This is exactly what happened. So, what went wrong? The orbiter was coded with metric units, so the thruster control unit was working with the metric unit for impulse, Newton seconds, but the controller was being supplied with pound force seconds, which differs by a conversion factor of 4.45. A massive discrepancy. A discrepancy that destroyed a $328 million project.
Oh, that's it?
In 1983, an Air Canada flight departing from Montreal ran out of fuel halfway to its destination in Edmonton. Why? The ground crew knew 22,500 kilograms of fuel was needed for the flight. They, however, needed to calculate how many liters were needed to be pumped. So, they used the density ratio to convert the weight measurement to a volume measurement, but they used the 1.77 density ratio, which was pounds per liter, instead of the correct ratio of 0.8 kilograms per liter, resulting in less than half the required fuel load being pumped aboard.
You know, I can imagine that, not being on one single measurement system, like everybody being on one single measurement system, has caused quite a bit of headache and, in some cases, real issues, as in that plane he's talking about. Wow.
Luckily, the pilot managed to glide the plane down to an abandoned airfield, but that little boo-boo of a conversion error could have resulted in a catastrophic loss of life. These are two cautionary tales with disastrous consequences, but it tells you nothing of the silent screams into the void every engineer in the world lets out when they are forced to work with both units.
I don't get that. You would think that, if you're going to be in a science field, you're going to be in engineering, knowing metric, considering that it's the universal measurement system of science at the very least, everybody would know that and they would just use metric. I would think the imperial system, if used, would basically just be used by regular people, in just, regular daily, life, not when you're actually trying to do something with engineering or other types of science. You know what I mean?
It's just an unnecessary pain in the ass we could all do without. This is the reason we need to choose one measurement system. Mixing units not only is tempting fate with conversion errors, but it costs an untold number of hours for scientists and engineers around the world.
No, like I said, I agree with that. It's just, when I think about myself as an adult now, if I go and weigh myself, for example, or if I go and I want to measure a piece of wood or something because I'm building something in the backyard or something like that, I don't really personally need to know metric for that. But I do believe, since the majority of the world uses metric, the US, at least when it comes to science and things that can have real world consequences, everybody needs to be on the same page with the same measurements. So I definitely believe that in US schools, at the very least, they need to teach metric to a certain extent, at the very least. And obviously, when you go into higher education and whatnot, metric definitely needs to be learned for people going into the sciences and whatnot, because it just makes sense. If you're going into science field, you should probably know metric because you're going to probably need it. People like me, I've never really needed metric before. I want to learn it because I find it will be interesting and, it could come in handy, but I'm not in a science field. So it's not something I feel like is going to be a life and death situation for me. I just kind of want to know it because why not,
Banging their head against tables, when they could be using that time for something more productive. I could end the video there, but we need to really hammer home why metric units are the superior units. So why is it better? Well, let's start with the fundamental unit of measurement. There are 7 base units of measurement, and with these 7, we can measure everything in the universe. Think of them like the 3 primary colors of light: With these three colors, we can create any color in the universe by mixing them in just the correct proportions. We can do the same with these fundamental units of measurement. They are time, length, mass, temperature, electric current, chemical amount, and luminous intensity. With these measures, we can describe our universe. Velocity is a combination of length and time, volume is length cubed, density is volume combined with mass. These measurements are the language of the universe. So, let's see how the imperial system handles a very simple one: length. An inch is a standard unit of measurement for length in the imperial system.
Right.
Let's imagine a scenario. You are designing a railing for a 1 mile long bridge. You, as a skilled and knowledgeable engineer, know that 2 half-inch bolts are more than enough to secure the railing down. The posts of the railing are 6 feet apart. Alright, how many inches are there in a foot? 12? So that's 72 inches. Every 72 inches we need 2 bolts. Our bridge is 1 mile long. How many feet is that? I don't know off the top of my head, and a quick Google search tells me it's 5,280 feet. What's 12 inches by 5,080? That's 63,360 inches. Divide that by 72, that's 880. So we need to order 1,760 half-inch bolts. That felt cumbersome. Why do I need to remember all these numbers? Because imperial is a convoluted mess of measurement units invented by people who married their cousins. That's why. Now, let's see how much easier that is in metric. How many millimeters are there in a meter? It's in the name. Milli, 1,000. Now, how many meters are there in a kilometer? Once again, it's in the damn name, kilo, 1,000. Given a measurement in kilometers but want meters, just shift the decimal place over 3 places. No calculation needed. There is no room for error. It's a simply better system.
Okay.
Even within imperial, you have to constantly convert your units. Ounces to pounds, pounds to imperial tons, which for some reason differs from a metric ton by 1.6%. Again, in metric, there are 1,000 grams in a kilogram and 1,000 kilograms in a ton. In imperial, there are 16 ounces in a pound and 2,240 pounds in an imperial ton. Why? You aren't even following the same conversion conventions as your other units. This is insanely cumbersome. The chances of conversion errors even within your own damn system is high, never mind having to convert to metric. You know what's even more insane? The word for mass and weight in the imperial system is the same. Why? Because the pound was invented before we knew what gravity was. That's why. We just assumed mass and weight were the same thing, when they aren't. So, we have to specify in imperial whether we mean pound mass or pound force. I haven't been this confused since I watched Magic Mike. The most ridiculous thing about all of this, every single one of these imperial measurements are legally defined by the metric system. America is already using the metric system, and most of the population is oblivious to it. Freedom, America, guns, pew pew, hoorah! The foot is legally defined as 0.3048 meters. The pound is legally defined by 0.435 kilograms. Why? Because the metric system is run by the International Bureau of Weights and Measures, a neutral international organization whose sole mission is to create a global language of science, who America is a member of. And they have succeeded in an awe-inspiring way. In 2019, the final metric base unit, the kilogram, stopped being defined by human artifacts and is now, like all other metric units, defined by the laws of physics.
You know, it boggles my mind why we haven't switched over to the metric system. I mean, everybody else is, and based off of what he was just saying, I mean, it really is something. I mean, I would need to kind of, practice this a little bit, I guess, to really get it in my head, considering I've only ever used the imperial system. But looking at that, it's very simple. I could pick it up very quickly. And I mean, it's just, yeah, I mean, it does seem like it probably is easier. I mean, I guess for someone like me, I'm so used to the imperial system that, I my daily life, I don't have any reason to switch over to the metric system, but it does make me wonder, why have we kept the imperial system when the entire world is on the metric? It really doesn't make any sense. I mean, it's like, Why do we want to be such rebels in this way? We're always rebels. The U.S. is always like a renegade for some reason, but this is not really, there's not really a reason to be a renegade or a rebel when it comes to doing mathematics or measurements. I don't know. If anybody knows why the US has not converted over to the metric, please let me know.
In 2019, it ceased being defined by this hunk of metal and began being defined by Planck's constant, which is defined as 6.626 by 10 to the minus 34 kilogram meter squared per second. Of course, to use this as a definition, we need ways to define the meter and second. The meter is defined as the length of the path travelled by light in a vacuum in 1 divided by 299,792,458 of a second. Okay, so how do we define a second? A second is defined by the hyperfine transition frequency, which is the frequency of radiation which will cause an electron to jump from two closely spaced low energy states in a cesium-133 atom. Each of the base units are defined like this, using the unchanging language of the universe as its yardstick, or should I say, meter stick. It's a beautiful and inspiring language that transcends the realm of humans, and for that reason alone, you should strive to use the metric system. Understanding the language of the universe is a superpower, and there is no better place to become fluent in that language than Brilliant. Did you know that you...
Wow, guys, this was interesting. I must say, I'm gonna have to go back and rewatch this just to kind of fully pick it up and understand exactly what the different measurements were. But I already can see what he's saying in regards to the fact that this is definitely easier. Once you know it, this is something you're not going to forget. You know, it is when we use the imperial system, we definitely have to go through a conversion process to come up with different measurements. And it definitely takes a lot of time and is cumbersome. And for the most part, you're going to need a calculator. But when you can just basically move a decimal over to change the measurement, I mean, it totally makes sense. Yeah, I'm going to definitely have to kind of explore this a little bit more. I want to learn how to use the metric system fully. But all in all, I think he's convinced me. I think that's what I will say with this video. I think he's convinced me that the metric system, once learned, is much easier, much quicker. It just makes a lot of sense, specifically because everybody else is using it. And I'm not saying you go and change what you're doing just because everybody else is using it. But when it comes to something like the way you're measuring things, we really should all be on the same page because everything is so connected, especially in the science world. You know, everything is connected. Everybody, all these countries work together on projects and whatnot. And it is a little bit ridiculous if you're having to switch back and forth between the imperial system and the metric system on a project. You know, it just, that right there, you know, doesn't make any sense. Like I said, you know, in Americans' everyday life, if they're not really in a science field, there really isn't going to be many times they're really going to need to know metric. I've gotten to this age that I'm at now, and I've never really needed to fully understand the metric system. But, you know, why wouldn't you want to learn it? You know, it's something, you know, like if you're ever going to travel, which I have in the past traveled to other countries in Asia, and it's something I want to do again in the future. I'm definitely going to go to the UK and Ireland, hopefully in the relatively near future, hopefully. And it'll be nice to maybe know how to measure things in metric. So I'm definitely going to continue exploring this, and I'm going to go back and watch this video again, and I'm going to try to fully understand the metric system. And based off what I'm seeing, I don't think it's really that difficult to understand it. You know, do a little bit of practice, you know, watch a few videos. I think it'll be one of those things that probably come relatively quickly. But anyways, guys, thank you so much for stopping by. Please click that like button. Feel free to drop your comments or suggestions about this video or others. And don't forget to subscribe to continue to follow me on my journey to discover my British and Irish ancestry. Until next time, guys, peace.